Welcome to Crossville's webinar series about OpenShift disaster recovery. Today, we will be examining best options for disaster recovery with OpenShift. I am Todd Millard, Chief Growth Officer at Crossville, and with me is our Principal Architect, Brett Kugler. Today's event will be scheduled for about 45 minutes, and if you're really serious about OpenShift, we trust you it will be well spent. There's a few housekeeping issues to address first. Everybody's mic is muted, including mine in the beginning, apparently. So please use the Q&A icon on your screen, and we'll address some questions at the end. We'll have a little time period for that. If we're unable to get to your question, then we'll respond to you after the webinar by email. So today's agenda, first we'll have a quick overview of Crossvale, give you guys a little bit of understanding of who we are. Then we'll get into the disaster recovery content and walkthrough, which Brett will be leading that. Finally, we'll provide you with some solutions and commercial insights around disaster recovery. And then we'll do a 10-minute segment of time to answer some questions that you may have. Who is Crossvale? We are an award-winning Apex Red Hat partner. This year, we won the Leading Edge Award, and prior to that, the Application Platform Partner of the Year. Crossville has been helping clients for about 20 years with enterprise application platforms. We focus on everything from day zero, which is build and enablement of Red Hat platforms. Day one, development of solutions, so DevOps solutions, integration, cloud native application development. And finally, day two, operations and maintenance. We have the only complete OpenShift operational managed service, so don't settle for fully managed, Rethink managed services. We are a preferred Red Hat services partner for companies like Cinex, IBM, Dell, and Red Hat Professional Services. So this leads us to the disaster recovery overview. So today, you'll be talking about disaster recovery. Brett will be leading a lot of this. When everything's going right, disaster recovery doesn't seem like it's really urgent, usually because the fear of high cost outweighs the risks. But in the end, in this webinar, we hope you should learn that DR is not one size fits all, and it takes a well thought out solution to create a custom fit. By really understanding the workloads that you're running, or the environments that you're running them in, it is important to understand that even a dynamic containerized environment where workloads are treated like cattle and not pets, things can go wrong. And so you need to have that disaster recovery solution. And Brett's going to talk to you about some different options around that. And then I'll come back on in the end and talk about some different solutions that we have to help you with that. So Brett, without further ado, you're up.
Thanks, Todd. I really appreciate it. And welcome back for those of you who've been on some of our previous webinars, and just generally welcome to those who are new to our series. Just to start out with, let's talk about some of the bullet points on this particular slide. There are a number of things that you need to consider when adopting a DR strategy, and we've broken them down into essentially a tier list. But all of the items here are kind of the things that you have to consider when you are making choices around what your time to recovery is, how much do you want to spend on that, who can do it. There's a lot of things that kind of go into the conversation. So we'll see as we kind of walk through the different steps that how we can approach DR in a number of different ways to kind of hopefully fit in to everybody's usage model. Mike, if you wouldn't mind giving me control of the slide deck. Give us just a second here. Oh, thank you, sir. So we'll just talk about right kind of off the get-go, right? What are your options here? And we can talk about having multiple clusters, architecting our clusters in certain ways in order to be able to kind of span them across our data centers, or if we are just stuck with a single cluster, how do we how do we manage that? So that's really ultimately kind of the high level breakdowns of kind of where your DR strategy should start. And again, uh, each has kind of their pros and their cons, and we'll walk through each of these in kind of more detail in the next few slides. All right. So the other thing we need to consider is what kinds of failures can you actually have in a OpenShift cluster? So some of the ones that come immediately to mind is just failure of some of the components in the cluster itself. You lose a master node or a worker or an infra node, right? And with OpenShift 4, this has become a very easy problem to solve. The inclusion of machine sets and the machine API has really made working with OpenShift and managing OpenShift nodes a lot simpler. And so this is probably one of the most recoverable use cases that we could face, is the loss of a node, a single node. Something else we might consider is the loss of our persistent storage. So if our applications are heavily reliant on that storage, what is our plan for recovery for that, right? And the real process here is, OpenShift doesn't really have a storage element to it, right? We have storage connectors, and it understands persistent storage, but really the storage comes from underneath from your provider, whether that's VMware or Portworx or Ceph or something like that. So that conversation has to bridge not just the OpenShift cluster, but also your backing store as well. Additionally, we can have things, like loss of your internet connection, right? What happens then, or in the case of something very drastic, a natural event of some sort, a complete site failure. Those are very scary things. And when we talk about those types of things in context of DR, we really have to start thinking about, well, what is the impact? Because if you're losing a data center, unless OpenShift is the only thing you're running in that data center, you have multiple problems, and you have to figure out, a priority of how do you recover through that stack. And that kind of goes a little bit beyond scope of this webinar, but again, these failure scenarios, they can involve a lot more than just your OpenShift environment. So in that case, there's a definite need to have a priority list of recovery. Obviously, if your tier 1 business applications are all running in OpenShift, you might label that pretty high to recover. If you're really just using OpenShift as a developer sandbox, then recovering that cluster may be further down the list of things that you need to do in the case of a true DR event. So let's talk about the big boy solutions to start out with. These generally have a higher price tag associated with them from an infrastructure perspective. And this is typically when you're talking IT, DR, the kinds of scenarios that come up. So the big one, active, right? What impact is there if you lose a cluster? Well, virtually none if you've got everything architected correctly. You've basically got 2 different clusters on 2 different data centers, and they're sharing state in some sort of fashion, right? Normally that means that since we're not federating OpenShift clusters, your data store on the back end is where your state is shared, right? But your uptime is not impacted in case you lose one of those data centers. There may be a cutover of traffic, but ultimately traffic's load balanced across the clusters anyway. So limited impact there, but you're paying an extraordinary cost in infrastructure because you have to have 2 clusters with 2 sets of subscriptions always running. That's fairly heavy duty. The next option is kind of an active passive cluster design. And this again is fairly costly in the fact that you have to have multiple clusters and multiple data centers. But what we see here often is where clients will have a production cluster and a non-production cluster, right? And those will be physically separated. And then the failover scenario is simply your non-production cluster has enough resource capacity to offload some of your production needs. This isn't 100% solution. It could be if you wanted to just keep a dark cluster, so to speak. But again, then now you're kind of stretching your subs, and you're playing with, you know, kind of what's allowed and what's not allowed. And it really becomes more of a management task of it, right? How do you do that cutover? How do you validate it? But at least from this sense, if you're keeping everything synced, everything's tied together, new release comes out or a new version of the application, you turn up the passive cluster, you sync it, you turn it back down. It's a management step, but it's doable, right? And then you're not paying for that second cluster to be running all the time. Finally, this is a very popular option, is the stretch cluster, where essentially you have your cluster spread across, a single cluster spread across multiple data centers. And essentially, if you lose any one of them, the rest of the cluster is able to continue to function as long, and giving you time to add more resources to it and bring it back up to kind of full capacity. Now, one of the requirements architecturally is that those data centers, those master nodes, as you have them split across data centers, have to be within 10 milliseconds of each other, right? That's a etcd requirement, and therefore that is a little bit tricky. Now, the other thing you might consider here is actually having more nodes in a stretch cluster than you would have in a single cluster, and that's just to really lighten the load on the cluster if one of the sides should fail. So you might consider, you know, 4 masters or 5 masters. If you have infranodes, you might consider, you know, 2 and 3. So you could actually grow that stretch cluster a little bigger, which again raises the price a little bit, but gives you a better performant recovery, if you will, right? So then you have to also plan about, you know, making sure that your services are deployed properly onto the cluster so that they're split between the data centers, right? So you have to play with some of the affinity rules within OpenShift to make sure everything gets separated properly. Tier 4 and Tier 5 is kind of the traditional backup and recovery strategy that Red Hat has documented as kind of their recovery solution. And this is mainly what our demonstrations today are going to kind of walk through. The thing to remember here is, just like any other system, you have to make sure that you're doing this on a regular basis. Your backups have to be done regularly, and then you have to test. You have to test the restore process to A, validate your backups were successful, and B, make sure that you know what that process is before it comes time to actually have to do it in an emergency situation. So there's a couple of different processes here, and kind of lumps in a number of different topics. So for example, if we lose hosts, if we lose masters, you know, we can recover those master nodes, and we'll show you an example of that. We can back up etcd. You know, not so much these days, but in the past, etcd has been known to be a little swirly, and it could be really a challenge to get that recovered and get it all back in sync. And these days, it's really not quite so much of a chore. And we have an example of that for you as well. But again, when we're doing these backups, it just like any other backup process, where are you going to store those backups? How much do they cost you if you're in in public cloud, that sort of thing. You know, how much disk space do you have for these backups? So there's a lot of questions to ask, and then obviously the the cost in resource time, in people's time, in doing the recovery and getting the cluster back and all of that. Especially if, again, this isn't a fire drill that you do every day, it's going to take you a little longer. But let's look real quick at a couple of examples here. So we're going to run through an etcd restore process, and I'll kind of talk through it as the video plays, and try to get through this. I apologize. You might have to squint a little bit. I had to go get my other glasses, but here we go. So the intent here is that we've been regularly doing an etcd backup of our cluster. And this is something that is provided now by Red Hat. They have some scripts that you can run that just copies all of the relevant metadata and information out of etcd and creates an archive for it that you can go store wherever you want to store it, right? And this is really nice. It works pretty well, and so we're going to kind of set this up, get this backed up into a place, and then what we're going to do is we're going to fail the etcd cluster, right? So just, you know, I probably shouldn't have to say this, but word of warning, please don't try this at home unless your intent is to test this process, right? And then do it on a lab cluster. So we have our backup, and what we're going to do is we're going to log into our actual master nodes, okay? And this is, again, a practice that Red Hat says don't do, and for very good reason. This is CoreOS, and CoreOS is meant to be very independent and self-managed, right? So this is something that, you know, every good OpenShift admin will need to do. However, just make sure that you're being very careful when you're inside the CoreOS and working with the cluster directly like that, right? So we go ahead and remove, this is our little types, our little note here says we're going to make sure that we've removed all of the etcd information from the relevant masters, and that will kind of leave them in this weird limbo state, right? So here we're just kind of going through and proving that yes, all the etcd stuff is gone. It's no longer running. The container is no longer running on the node, and all of that, right? So at this point, we've now failed etcd, and our clusters would be in bad shape, right? And the interesting thing to point out here, and we kind of cut through it just to save on some time, is that we failed etcd on all of our masters. So this means that everything is in a bad state, right? However, Red Hat has given us these recovery scripts, and they do take a little bit to run. But all you have to do is run the script against the backups that you've made, and it will slowly build that etcd cluster back and then sync the master nodes again. Now, another important thing to remember here is that, or I should say another important thing to point out here is this process is changing. It's evolving. As a matter of fact, in 4.5, which is the latest current OpenShift release, this process has changed completely from what it used to be in earlier versions of OpenShift 4. So the scripts are different. There's fewer of them, and the way you work with them a little bit has changed as well. But all we do is we restore our etcd, we restart the kubelets, and then here we see that the etcd pod is running again. And we'll wait for that to come up on some of the other hosts. And as soon as they do, we'll see just a second, that all of the nodes are now running etcd again, right? So essentially, that's that. I mean, we've got a few more things to talk about here. However, ultimately, once you've restored it, all you have to do is go back to OpenShift and say, okay, now go ahead and patch this in. And what it's going to do is it's going to read or refresh its etcd data from disk that we've restored. And then it's going to go through node by node and make sure the revisions are updated. So this, again, this process takes a little while. It's not terribly long. It's about 10, 15 minutes. For sake of the video here, we've kind of shortened what's going on there. But essentially, we just kind of keep monitoring until the cluster has reached its final revision state, right? And you see here, we're kind of just checking, and there we go. Now we know that all the nodes are in, and they're all in the same revision. Now we can keep applying this patching to keep the revision state moving upwards, but at this point, we have recovered our masters, and the cluster is once again functional. Here you go. It says it's patched. All right. So that's what the etcd recovery process looks like. Now, again, I mentioned that was a 15, 16-minute process, right? And that's for somebody who knew what they were doing and had practiced this several times, and typos removed and all that sort of thing. So that's not bad, but that failure scenario is pretty specific to losing etcd, right? So what we want to look at now is, well, what happens if you lose master nodes? So you lose the physical machines, right? So we're going to set this up for kind of a failure scenario. And again, don't try this at home unless you're practicing, right? So typical cluster, 3 masters, 3 workers. And what we're going to do is, throughout this demonstration, we're going to use the machine API to recover, first delete and then recover these different systems. So a little prep work to start. We're going to actually back up what the YAML looks like for a master config. And then we're going to go into that YAML, create a couple of copies, and essentially make new master node descriptors inside of there. So what you'll see here, we'll go into the YAML. We're going to find the name of the machine itself, and we're just going to change that master number. In this case, we change it to 1. We realize pretty quickly that's not supposed to be 1 because we have master 0, 1, and 2 already. So in a second here, we'll go back and change that, and we'll create a master 3 and a master 4. So the intent of the demonstration is to actually remove masters 1 and 2 from the cluster, and then add 2 brand new masters, 3 and 4, to kind of compensate back in, right? To just kind of demonstrate that node failure. So come in here, get the right numbers in. So master 3, we'll do the same thing for master 4, and make sure that's where it needs to be, right? And then here we see that etcd is running, so everybody's still happy. We're going to R shell into one of the etcd pods just to take a look at the etcd member list, because this is kind of how you'll see what is actively participating in the etcd table, right? So if we take a look at the member list real quick, we'll see we have all 3 of our nodes, all 3 of our masters are currently participating. That's as you would expect, right? So the next thing to do is to go ahead and break the cluster, right? That's why we're here for. So we'll give them just a second to get over there, and Here we go. OC delete the machine, and then tell it what machine we want, master 1 and master 2. And OpenShift is, very happy to do that for us. Okay, sure, we'll just delete your masters. No problem, right? So if we start looking at what's going on the cluster, we see that we've got pods terminating. We'll see that, things are starting to become unresponsive. However, if we log into the one master that we didn't remove and we look at that master's etcd table, we'll see that it still thinks that all of those things are part of the cluster, right? So step one in this process, if you lose a host, would be to remove the host that you lost from the member table. And this, this is one of those best practices kinds of things. You're never going to recover that master. It's never going to come back online. If it were to, you actually don't have to go through this step. If you actually recover that actual master machine, then it'll come back in and it'll rejoin the cluster, and it'll be like things never changed, right? However, we're not doing that. In this case, those things are gone. We've taken them out on the back 40 and said goodbye to them, right? So in this case, we remove those from the etcd table just to make sure that everything's nice and clean before we go and then bring the new nodes back in, right? So just take another quick look at the state we're in, and we'll see now our cluster is actually fairly unresponsive. That's because we're down to one master. The API server is getting hammered. Everybody's trying to figure out what's going on. So there's a lot of noise in the cluster right now, right? When it's down to this one master, we're in this emergency situation. So let's fix that. Now, we saved off our YAMLs for the machines earlier. Now, all we have to do is apply those, and through the machine API, OpenShift will create new master nodes for us, right? So we've created master 3, and now we've created master 4, right? And we're going to kind of keep an eye on this as they come up and see what happens. But essentially what's going on behind the scenes is it's rebuilding those masters, redeploying all of the master goodness that goes out there to run, and then the etcd pods start to spin up. And if we kind of go and look at the etcd table, and again, this has been shrunk down. I don't want you guys to think that this is all happening at this pace. This does take a little bit of time. I think my engineer took about 45 minutes to go through this full process with, typos and retries and that sort of thing. So it is ultimately this simple, if you want to call it that. Here you'll see that just by applying those machines and getting them recreated, they've added themselves into the cluster, and now we have three members in the etcd table. So that is the recover a master node scenario. All right. So let's talk about the other end of the spectrum, right? What options do we have if we don't want to spend a ton of money on extra hardware and subscriptions, if we don't necessarily want to do it the old traditional IT way of backup and restore? What other options are there for disaster recovery with OpenShift? And this is an approach that we at Crossvale actually take a lot, and are very, very excited to see clients adopt. And this automated rebuild, now you do suffer a little bit longer downtime. So it's going to depend on your risk and how long your mean time to resolution can be, and all of that, right? However, being able to rebuild a cluster and redeploy your applications on the fly is something that is kind of right in line with the mentality of OpenShift anyway, right? This idea of pods that can be thrown away at a moment's notice and just create a new one to carry on. Why can't we do the same thing with the infrastructure? Now, we do have some challenges in that we have to make sure the applications can handle that, make sure that we have the right skill sets and people who can create and maintain the scripting in order to launch that, right? We have to have a GitOps practice. We'll talk about that in a little bit. But there's a lot of great value here that you can recover a cluster without having to have all those excessive resources hanging around or managing backup and restore processes, right? This is really that recreate. And then finally, the manual rebuild, which is kind of exactly what I just said, but worse, right? It's the slogging through all the steps independently. This has to be something that's well documented. Your guys are trained on, and you know, you will lose inherently some information out of your cluster. It's just going to happen. So, you know, terrible option, but at the end of the day, you know, if you don't have a DR plan today, that is your DR plan, right? So certainly think about, you know, some of the other options in this list, and you know, come talk to us if you are interested in more of the GitOps approach, right? So what is GitOps? That's a whole nother topic, right? I think it's fairly well discussed here, especially I think in the last 12 months, it's gained a lot of traction. Everybody knows about DevOps, right? And GitOps is really kind of an extension of DevOps, and it's really meant for your infrastructure components in rebuilds, right? So this idea of declarative infrastructure. You ask a system, such as Ansible Tower, to put you in a state, and it goes and does it, right? And it knows how to do it. Of course, you have to build that infrastructure. You have to build those components. But once it's there, you can do it as often as you want, and that makes it, you know, much quicker to get things redeployed. And you can have, you know, automations, approvals and notifications and all of that rolled into the process, so everything's controlled. And you can do that soup to nuts, right? You can go all the way from your infrastructure through to your applications, including redeploying your CI/CD pipeline and then redeploying your applications. So kind of the whole collective, right, is automated and built for Recreate. Let's talk a little bit about some of the options out there from various sources, right? And some of the questions that you might have now that you kind of watch this and gone, well, wow, all those DR situations sound unappealing, right? So what about some of these services, public cloud services, Red Hat Dedicated or Azure Red Hat OpenShift? You know, what do they provide in a DR scenario, right? And ultimately, it's kind of hit or miss there as well, because you're really turning over the management of the control plane to those providers, which is great. You won't lose masters or anything like that. But on your end of the spectrum, if something happens to your applications or your application stack, that's still on you. They're not going to help you with recovering your applications, right? And then, of course, they're cloud-only offerings, right? There's no on-premise solution for those services. Vendors are trying to make this a little easier. Portworx has a good solution across the board for storage and recovery and all of that of your persistent storage. Catalogic has a QBDR product. These are all, I would say, in their infancy, right? They're all very new and still growing, and some of them are very vendor specific, right? And same thing with storage itself, right? Any of your storage platform providers generally come with some sort of strategy for backup and recovery, redundancy, all of those types of things, but they're tied to that vendor, right? So you're kind of bound by who your provider is. So again, it's a little bit of a messy environment, and it can be kind of hard to find out, where you lie, what your best options are, and it's not a one size fits all conversation. Everybody has their own needs, their own levels of risk tolerance, and frankly, their own size of their checkbook. So it really depends on where you're going to land within that spectrum. Now, we at Crossvale kind of like this idea of the recreate, which I mentioned, but maybe along with something with like stretch clusters, right? So getting kind of the best of both worlds, where we can keep you running as long as both data centers are up, and then have a way to recover from a deficient system because you've lost the data center more quickly through a GitOps process. And that's really kind of what we think of as the pinnacle of DR right now. Again, it doesn't necessarily fit everybody's use case. And with that, Todd, I'm going to throw it back over to you.
Thank you, Brett. Appreciate that very much. Hold on, just sorry, working from home and the baby's outside the door, screaming at the door. So yeah, I appreciate that. That was a lot of information about DR. And so when we take a look at what Crossvale can do to help with this, our Crossvale efficient risk model is something that we do to help our customers when it comes to analyzing and understanding their DR situation. So what we do is we come in, analyze your current situation. Not all situations are equal. We need to assess your current strategy. Maybe you have a vendor neutral strategy. Maybe you have a strategy where you're trying to align with certain vendors. But this strategy, we help you understand, okay, what is the current strategy? Like if your current strategy is a tier 7, you're going to have to rebuild. Like how long is that going to really take you? Can your team actually do what they need to get that done? So we validate your risks then by understanding your applications, understanding what your risk models are, how long something can be down, and do this by each type of application and also in each cluster. Like how does all this lay out so that you can actually properly have a way to deal with loss if there is a loss, and how that recovery is. We review the customized options. So we come in and take a look at kind of a multi-tiered approach on this, where in certain applications, certain clusters, there are certain types of recovery strategies, while in others, maybe the strategies are a little bit more aggressive. Also, as a CCSP provider for Red Hat, this means we're a certified cloud service provider. We also have the option to be able to supply our customers with subscriptions that you don't have to buy by the year. You can buy in shorter periods of time to help cover these kinds of strategies around DR when you have that DR requirement. Also, we take a look at understanding your to-be model. So where do you need to go? Like the workloads that are coming up and the things that you're going to be doing in that cluster. Let's build a strategy so it works for you today, but also grows into where you want to be. And then, of course, our team is talented. We do the build, the test, validate. We also have a managed service team to be able to deal with maintaining your strategy across all your environments as well, if you want us to maintain that for you. Let me move on. And as we take a look at here on the difference in this, our goal is to kind of find this area where we're able to give you an efficient risk model, where the amount of resources that it takes and the amount of effort that it takes crosses that risk path right at the threshold where it works well for you. Because like I said, every environment is not equal, and it's a matter of finding the one that's going to be the most efficient for you. How do you build that solution? And it takes a talented team to understand what all the options are, and also to ask the right questions to know how to build that proper model for you so you're not overspending. Like a good example of this is like if your applications maybe aren't built to be stateless, and there's ways that we could come in and we could help you understand how to refactor your app instead of going buying active clusters and spending a lot more money continuously. Maybe there's a way we can come in and help you refactor your apps and then use a model that might not cost you as much to sit there just in case of a loss. And then at that same time, you're also modernizing your applications. So you're getting more use out of that money rather than just having it sit running in an environment that's maybe an active passive or an active environment where you're not getting as much value out of it, only in case of a failure. And then we take a look at the benefits of Crossvale OpenShift DR services. We say you want ERM, which is our efficient risk model, not necessarily just DR. A DR strategy is very static. Like what we want to do is we want to work with you on building you a non-static DR strategy. This is going to be one that's going to flex, that's going to meet the needs of the current DR situation. A mixed tier approach could serve you better. Not all the environments and failures are equal. And it's a matter of finding how to minimize that downtime and at the lowest cost, but also not put so much risk on there that your clients or your internal resources are not getting what they need. How applications are developed and architected can simplify or complicate your strategy. So just taking a look at what you have and then trying to figure out how to build the DR strategy about what you have, the best approach might even be take a look at what you have and refactor some of that to have a better DR strategy. And how do we take a look at that over time on where the priorities are on your DR strategy? Thinking outside the box with flexible consumption models can create a more efficient DR solution instead of just taking, the static way of solving this problem. Like in the past, we're moving to a dynamic world in orchestrated containers. So now let's take a look at how do we move to a consumption model for our DR so that you're not paying for that until you really need it. And then employing a team like Crossvale Managed Services where we'll help you with your DR events, somebody that's there that their entire job is to know this platform inside and out and understand what your strategy is, and then be able to implement that strategy very quickly so you have the least amount of risk when there is an issue. Trying to move to the next screen here. And then, so if any of you guys are interested, you take a look at this and you say, yeah, we're still trying to figure out exactly what our DR strategy is, or, we think we got it kind of figured out, but it'd be interesting to get, a better look at this. We're offering a free disaster assessment on your OpenShift clusters. So, reach out to us at Crossvale. You can either hit us through, through crossvale.com. And say you're interested in the DR assessment, or reach out to somebody who invited you to this event in order to get that assessment. And we'd love to kind of take a look at what you have going on, understanding that Crossvale has lots of consulting solutions that we have that are very prescriptive, and we go in and we say, we know what you want, we have this prescriptive approach. But when it comes to DR, it's very custom. We need to create something that's going to really meet your needs in a way that isn't one size fits all. It's the size that fits you. So as we come over and take a look at questions, I see, can you explain the issues with persistent storage in relation to OpenShift DR? Brett, can you tackle that? Maybe talk about the persistent storage issue in a little bit more detail?
Yeah. So let's define persistent storage just real quickly, right? This is an application level issue where it needs to know something about itself or its operating environment or the data that it's consuming, right? And typically the way applications have done that in the past is either writing that information to a database or writing that information to disk, right? A file, something like that. In the latter case, that's what we're talking about when we're talking about persistent storage. Now, databases are persistent storage as well. However, in the context of OpenShift, generally those are talked about separately. They either run in a separate namespace or they run outside of the cluster entirely. So we're really talking about the application managing, files and information locally on a disk, if you will, right? Everything is obviously not quite so simple in this containerized world of ours. Um, and so if you are tracking data that way, then what happens when you lose that data, right? If the pod gets disrupted, if you lose that node where that data was stored, what happens, right? How do you recover that? And that's a tough question, right? Things like a good example would be something like the AMQ brokers, right? AMQ is a messaging system, and it streams messages that are buffered onto disk in case there's some sort of outage. It can recover those, right? But you know, that's persistent storage, and that has to be retained. So generally speaking, you're going to fall back on your storage system to manage that persistent storage for you, either through replication or through backup and recovery. Those are really your options. Replication obviously requires more hardware, more disk space, but generally has a lower time to recovery, almost zero if it's working the way it's supposed to, versus backup and recovery, where you can actually lose data over some significant period of time based on how quickly you're doing your backups. So it's kind of a touchy issue. Again, it falls back to who's your storage vendor, what you know, CSI plugin are you using. There's a lot of questions around persistent storage, but ultimately, when it comes to things like recreate and all that, that is the key thing that we look at. Say, okay, how do we deal with this?
Okay, and we're a little over on time. I'm just going to throw one more question out here because this probably is good for a lot of different people. Do you have a strategy that works better for AWS versus on-prem?
Oh, you know, it depends on your deployment, I guess. If you're doing VMware, then things like the recreate strategy work just as well on VMware and any public cloud. If you're going out to, say, like bare metal, that's a little more you know, questionable. There's a little heavier lift there, but AWS does have some tooling around it, and not just AWS. You know, all the major cloud providers have tooling that are kind of really driving that model of automated deployments and you know, automated snapshotting, backups, and all of that. So they, you know, they bring those services with them. Not that you don't have them on-prem in your data center. You know, if you have vCenter in there or VMware in there with all of the tooling, and you know, your teams know how to use that and all that, you can build some similar um, ecosystems, right? But essentially, it's not really, you know, obviously it's easier to scale hardware in AWS because, you know, they have unlimited hardware, and as long as you can pay the bill, they're happy to give it to you. So there's some restrictions there on, you know, the physical side of the house where it might not be as easy to scale. So again, I think, Todd, to your earlier point, DR is it's a big conversation, and it involves a lot of different questions, and it's not one size fits all. So it's really important to think about that very clearly as you're planning out your strategy.
Yeah, as you were saying all that, I was going to say, it sounds like your answer is it depends.
It always depends. That's right.
Right. So thank you, everybody. We're a little over on time. Please reach out if you have any additional questions on this. Please take 2 minutes to fill out the survey after this meeting. It'd be really important to us to be able to understand our webinars that we have out there for the public. And thank you for attending. Like I said, reach out. You can come in through crossvale.com or reach out to somebody who invited you to this email. Michael Boyle over there in EMEA, or myself, or Ken, or Amy over here, kind of on the North America side. Appreciate your time. You guys have a great day.
Thank you.